So this is a lecture video on proportioning ratios. Right now I'm taking this from B4 of your module under Learning Task 2. I'll get the page here. Page number at the bottom, 27. Okay, proportioning. So this is the main concept I want you to take away from ratio and proportioning. Understanding that when you proportion two things, it is suggesting they're equal to each other. For example, the ratios 1 to 2 and 2 to 4 are equal, so they're said to be proportionate or in proportion to each other. That's why we can use math concepts like cross multiplication, knowing that they're proportionate. You can also use it to find out if they're proportionate, is what they're suggesting here. And they say to cross multiply fractions, multiply the numerator of one to the denominator of another. So numerator of one to the denominator of another. 2 times 3 equals 6. 6 times 1 equals 6. Then we know that they're proportionate to each other. And here they use a drawing that has a scale of 1 to 100, which can be written by 1 over 100. Using that ratio, a beam span on a drawing measures 4.5 centimeters long. So scaling from a drawing to real life, knowing that the scale of the drawing is 1 to 100, we can then determine the actual beam span by putting the two ratios next to each other, cross multiplying these two and dividing by that, and we get 450 centimeters long in real life. So using a sample problem math worksheet, I'm going to use this video to go through these concepts. I'll also be introducing Pythagoras as a way to get to the solutions that you need. Okay, so this sheet deals with 3 different problems. Here's the first problem, here's the second problem, and here's the third problem, which is a little more complicated. And this one we'll be dealing with Pythagoras. Okay, so the first problem deals with 2 triangles, proportionate to each other, different sizes but proportionate. Okay, first thing we want to do is separate the 2 triangles away from each other. Get a good visual. I've done that here. Okay, so I've pulled the 2 triangles away from each other, and now I can easily see that the x value on this triangle is proportionate to the 280 value on this triangle, and the 100 value on this triangle is proportionate to the 250. And I write it in this fraction form. This allows me to visualize the math much better. So our task now is to isolate for x, trying to figure out x. And we do that following the rules that we just went over. First, we cross multiply these two to get the 100 away from this side. That'll isolate for x. So x will equal 28,000, the 100 times the 280. And we just need to finish our math by dividing 250 into 28,000, and we get an answer of 112 for x. This is the second problem. Same concept, visually a bit different. Now we have the triangles written upside down and within each other. Don't be fooled. Follow my suggestion. My suggestion is pull the 2 triangles apart. So I take this triangle and I make it its own, recognizing that the x value and the x value and the 125 and the 125 can be drawn proportionately to the full triangle, this one here, which I've drawn over here, and keeping the 500 value, you can't quite see it there, but 500 value on the top and to get this dimension of the triangle, I have just added these two together. So now we have two proportional triangles. Now that we can see them clearly, I am going to write them in fraction form once again. So I'll take the x value and put that on the top, and on the other side of the equals sign, I'll take the 500 because they're on the same side of the triangle. On the bottom, I'll take the 125, and on the bottom over here, I'll take the 285, proportionate to each other. Now we're back to what we just did. We're going to isolate for x, multiply these two together. Now we have x all on its own, and then those two equaled 62,500, and we just need to divide out 285, and your answer for x becomes 219.29. And don't be too concerned about what's after the point in this situation. It's more relevant that you get the concept. Okay, the third problem on this worksheet forces us to use Pythagoras to get some unknowns here. Okay, we have a large triangle, a medium-sized triangle, and a small triangle. I've decided to, using what I have, what I know, which is 495, and I also have these three dimensions which I can add together to give me a total length along this line. I have those two, which means I can figure out the total hypotenuse. And how I'm going to go about doing that is I'll use the Pythagorean theorem by Pythagoras. A squared plus b squared equals c squared. A being either this line or this line, and b being either this line or this line, c always being the hypotenuse of the triangle. So taking what we know from the big triangle, I've given them their values a, b, and c. Let's find c. How do we do that? Well, we take our Pythagoras formula, punch in 495 and 603. Those numbers get really big when we square them. And add those together, and we get a very large number, and that number equals c squared. It's important for you not to mistake this large number for the value of c, because this large number is the value of c squared. So we need to get that squaring out of there. And we're going to go to a math rule now. What we do to one side, we do to the other. So to get rid of the square on the side, we're going to square root that, like we've done down here. And if we do that over there, we have to do that over here. And we get an answer of 780.1 for C. Excuse me. Now we have the information we need to find the rest of the unknown quantities. So this question is asking us find x, y, and z. So we didn't find any of those yet. What we found is the total dimension along that triangle. I'm going to call that my magic triangle. I'm going to use that whole large triangle to figure out the sides for the rest of them. So in this situation, I want to start with the smallest triangle and proportion that off against the largest triangle. So this smallest triangle is asking me to solve for z. So I'm going to proportion the z and the 230 up against the hypotenuse of the large triangle, which is 780.1, and the bottom dimension, which is proportionate to 230, which is 603. Now we're back to what we did in the previous questions. We're going to isolate the z, cross multiply, divide, we get 297. The same concept applies to finding y. The only difference being we need to figure out the hypotenuse of this triangle, realizing that the hypotenuse of this triangle will be y plus z together. So we write it a little differently. The y plus the z is proportionate now to the hypotenuse of the big triangle. And the bottom dimension of each of those triangles are proportionate to each other. So in this case, I've taken the 201 and the 230, added them together, and that's proportionate as well to the 603 on the big triangle. And that's what I've done here. So we're going to do the same method, try and isolate for the letters first. So we're going to cross-multiply the 431 and the 780, get this very large number, divide it by 603. Once we divide it, we get 557.5. The 557.5 is the total value for the hypotenuse of this triangle. We're trying to find y. We know what z is. We're going to subtract now. Again, a math rule. What we do to one side, we do to the other. So we're isolating for y. Take the z out of that side because it's added, minusing it. So we also minus to this from this side. That z value being 297.5. I didn't write it in here. That's what it is. So it's 557.5 minus the 297.5. So our value for y becomes 260. And the final piece of our puzzle is the simplest of all. Now that we've found y and z, or z, and the hypotenuse of the large triangle, it's simple enough for us to isolate for x by taking the total hypotenuse of the large triangle and minusing y and minusing z. And that's what we've done here, and we get a value for x of 222.6. So in this video, we've gone through ratio and proportioning triangles and solving Pythagoras to get what we need to ratio and proportion triangles.